on extreme weather and climate events. We're going to talk about high-end climate change, and it's my pleasure to introduce Andrea Tilke, who is the head of unit for climate action and Earth observations at the Directorate General for Research and Innovation at the European Commission. Welcome.
Thank you, Miguel Angel, and I'm very happy to be here with you today and to open this and to set the scene for the panel on high-end climate change. High-end climate change is a subject that we started investigating some years ago. So not we, but we proposed to the scientific community to investigate through launching a specific call for proposal, to which both some of the people today in the panel have represent the main project that came out. So Richard and Tim with the projects Helix and Impressions that have been working this year very well on this subject. For sure, it's an important aspect because we are seeing an acceleration of the impacts of climate change, and there is a growing knowledge and on the fact that today the human influence on climate is having also impact on the extremes. So a report that is published every year by the Bulletin of the American Meteorological Society explaining extreme events from a climate perspective reveal how human influence on climate has led to some major extreme events. Now, for the first time last year, in 2016, researchers have identified extreme events that would not have happened without human-induced climate change, without anthropogenic warming. So this is different from the past where there was a combination, but now this is coming up to the stage. So the consequences for risk management, disaster preparedness are clear. We are not only changing the intensity and frequency, but now we are pushing extreme events beyond the bounds of natural variability. So the question is how to prepare societies and are the societies prepared, first of all, and how to prepare them, and how can we work together to enable effective adaptation. We have the Paris Agreement that has set global goals, and we are working and trying to lead at world level to avoid dangerous climate change by limiting warming to well below 2 degrees. But you all know that this is a very difficult and very challenging fight. We have to be in some way aware that of course, we will work and we will do all possible to reach this, but this might be reached with some overshooting, for instance, for a period of time. And therefore, overshooting may expose the world to limits of warming that are beyond the 2 degrees average, and that may trigger maybe other tipping points, maybe create scenarios of extreme events that are much more complicated to manage. So later this year, the IPCC will publish its special report on the impacts of global warming of 1.5 degrees above pre-industrial levels. This will provide to all of us key information on vulnerabilities, impacts, and risks of a world that has warmed by 1.5, taking into account adaptation potential, our limits to adaptive capacity, and considering the consequences, as I said, of potential overshoots. I have to thank also some of the projects that are here present today, because they accepted our request to change a little bit their programs and work on the 1.5, because some years ago, when after the Paris Agreement, we were taken a little bit by surprise of seeing that there was this request of UNFCCC to have a special report on 1.5 degrees, and there was almost no literature available on 1.5 degrees. So we called here in Brussels 55 coordinators of our projects ongoing on climate change and similar, and we asked them to reprogram some of their work on that. And this was very successful. And I guess that if we will have an interesting and important report at the end of this year on 1.5, it will be also thanks to you and to the action of the many scientific, the many scientists in Europe that have taken this very seriously. And I'm also delighted to see our colleagues from Adaptation Unit in DG Clima and the JRC presenting the outcomes of the PESETA 3 project. So I hope you enjoyed this panel and have a very fruitful discussion the rest of the day and the week. So thank you very much for your attention.
Thank you very much, Andrea, for this great introduction for our panel. So, yeah, it's a pleasure to be here today as both the chair of this panel, but also the co-convener of Theme9 on extreme events. I think we've had a great time organizing this session, so I hope you enjoy the panel and the rest of the day. So what's the intention behind this, having this high-end climate change in a session during the community of users meeting? Is to expose this community, to expose all of you to the risks of rising global temperatures and the impacts, and also the potential implications for extreme events. Do we know what's coming our way? And as Andrea said, are we prepared for that? So that is what we are going to be discussing with this excellent panel, and I'm going to be introducing them as they speak. So first of all, we have Manuel Carmona Yebra. Manuel comes from the Directorate General for Climate Action in the European Commission, and he works in the unit dealing with climate change adaptation. So, Manuel, all yours.
Thank you, Miguel. Hello, good morning. Just going to test that this works. Yes, it does. Good morning, everybody. So, to talk about high-end scenarios, we might as well start with low-end scenario, perhaps where we are now. I come from the south of Spain. My parents come from a village in the southern mountains of Spain. When I was little, I used to go with my dad for fishing in the river of the village. He used to fish trout, and we brought it and ate it at home. Okay, I'm not so old, but if you go there now, well, there are no trouts, but there is no river either. The chestnuts that were part of the ecosystem around the village are dying. They can't handle pests that flourish with warmer temperatures. As I said, I'm 43 years old. So I guess this is why, a very personal reason why I came to work on climate matters. This is low-end climate change. So what is high-end? Where are we going? On this, I have learned a lot from some of the people present here, by the way, of projects like Helix, Impressions, the JRC, PESETA project, magnificent work done by H2020, on which we at policy DGs are very thankful. They come up with inconvenient, let's say, questions, paraphrasing Al Gore, inconvenient questions like, what happens if the Paris Agreement doesn't work? What happens if we have to handle in the future temperatures of 3 degrees, 4 degrees above pre-industrial times? What does it mean for Europe? What are the limits of adaptation to climate change? And what is the cost of not doing anything, of not doing mitigation, not doing proper adaptation to climate change? Well, on this, On the cost of inaction to climate change, there are currently more projects on DG Research on Horizon 2020 going on, and trying to gather a literature review on what will be the cost. That's in the slide that I wanted to show you. And you will see a range going from, I don't know, 200 billion, 100 billion per year in the 2050s to 2080s with 700 billion. This doesn't include all the economy. It's just a number of sectors. It's a very rough estimate at the beginning of a project. So this is a big disclaimer for you. These are very, very rough figures. But it gives you perhaps a scale. We'll probably hear later from the JRC on other sectors and other research that they are undertaking on costs. I want to divide my small presentation in two parts. The first one is what is Europe facing and what we're doing. And the second on a number of themes that I thought would be interesting for discussion. So first, on what Europe is facing for climate change. Well, the global temperature might be limited to 2 degrees, but make no mistake, in Europe, we will be over that. Europe is warming faster than the global average. So 2 degrees at global level might mean for some areas of Europe, 3 degrees, 4 degrees. So, compounded by the fact that the impacts will be very different across Europe. As far as we know now, and as it was shown in some of the slides we saw earlier in this morning, the impacts will be not only qualitatively different, but also quantitatively very different in the north of Europe, the south of Europe. They tend to be more dramatic in the south of Europe. Mediterranean countries becomes an arid area. Water stress is an important condition for economic development, so it's a big limitation in the Mediterranean countries when they will become dry, not to mention forest fires, etc. So we have an element of the cohesion policy here at play, differential impacts across Europe. The climate action policy, if I mirror a bit what happens with the Paris Agreement, in the EU is centered about 3 elements: mitigation, adaptation, and finding the money, financing climate action. For mitigation, you're probably aware, the emissions reduction. We have made big progress over the last months because now we have in place the framework that will cut emissions by 40% by 2030. And the elements that are in place now are the emissions trading system, after 2020, the LULUCF, so land use change and forestry regulation, and also the effort sharing regulation, the national targets for sectors not covered by the ETS, the emission system. So that's for mitigation. The second element of EU policy, adaptation. That's where I work, adaptation to climate change, where there's a strategy that was adopted in 2013, and now we are evaluating it. By the end of the year, you will be able to access online the results of this evaluation, seeing what the EU has done in terms of adaptation to climate change, and have an idea of what worked, what did not work. In this process, stakeholders, possibly some of you, have been involved and have been consulted. The third element, financing climate action. There, in the current multi-annual financial framework, we had a target of 20% of expenditure on climate action. For the next multi-annual financial framework, you probably have seen the news. We are hoping to have, at the end of the decisional procedure, which takes long, 25% or more, an increase in any event. And also, I would like to mention the action plan on financing sustainable growth, which will try to establish a taxonomy of green investments so that we all know when we want to invest in the economy of the future that these are reliable green investments. Lastly, in this part about the EU, I don't want to take too long. I wanted to mention the ongoing work that implicates the whole of our Climate Action Directorate General, the work on the long-term strategy. The Paris Agreement invites parties to present by 2020 a long-term strategy on emissions reduction, and the whole Climate Action Director General is working on it. We are also trying to establish adaptation as one of the preconditions to deliver the mitigation targets, because adaptation is about social and economic stability, about having a territorial cohesion, fairness in the impacts on sectors, having these elements as part of the efforts to decarbonize the economy in the long-term strategy. I would like to announce that there will be a stakeholder event on the 10th and 11th of July, hosted by Commissioner Cañete. I would think that the registrations are now open, will be open soon for stakeholders. There will be space, I think, for around 2,000 people. Some of you might be interested to attend this. 10th, 11th of July here in Brussels. Now, very quickly, I would like to throw now and put on the table three very, to me, interesting issues linked to high-end climate change. One of them being hurricanes. The second, tipping points, mentioned by Andrea in his introduction, and also the links between security and climate change, something that you probably know more than me about. But in any event, I want to stress the links. So first of all, hurricanes. Well, they are the poster child of extreme events, and I myself, tend to think of them as happening somewhere else, you know. If I can show you, I got 2 minutes, okay. If I can show you the map, you know, exotic places, so why should we care? Well, of course we should care, but also, even in a more selfish point of view, there are EU citizens that will be affected. There are outermost regions of the EU located in these areas. We tend to forget that there are 9 outermost regions, and some of them, in particular French regions, the Caribbean, will be affected by hurricanes more and more. I want to remind Irma passage via Saint Martin last year that caused devastation. The second interesting point I wanted to mention is tipping points. Now, we don't know much about the biophysical tipping points, even less about the economic impacts that they will bring to Europe. Tipping points are points of no return in the climate system, and we basically don't know what comes afterward. One that is probably close to home is the Alps. At 2 degrees of warming probably will mean a 3-4 degrees of warming in the particular region of the Alps, which then means a complete loss of glacier ice and deep impacts on the economy of the region, on water availability, and on ecosystem and biodiversity. So they are closer to home than we think, and perhaps closer in time than we think. Third thing, and last, is the links between climate and security. Now, this is just a picture. It's a flooded landscape with security officers trying to solve the problem. This is something we might be facing more and more in the future. The topic of climate change and security has been under the EU radar for 10 years now, at least, and there is now a new global strategy for the EU foreign and security policy that expressly makes the link between security and climate change. There's an early warning system for conflict prevention in the EU that now takes into consideration climate change as one of the criteria to evaluate the risk of conflict. Even in the Security Council of the UN, this has transpired, because you will know that there are some resolutions, recent one in March, in fact, that have recognized, although not as expressly as the EU policy, it has recognized the link between the changing climate and problems in the Lake Chad region or the Sahel. On this, by the way, there's an important event on the 22nd of June hosted by Vice President Mogherini, a high-level event on climate, peace, and security. Note the 3 concepts together. So, sorry it took a bit longer than expected. I hope you found it interesting, and I look forward to hearing your questions. Thank you very much for your attention.
Thank you very much, Manuel, for an excellent presentation and for providing the perspective from DG Clima. We'll be taking questions at the end, so we can discuss them as a panel. So it's my pleasure now to introduce Juan Carlos Ciscar from the Joint Research Center in Seville. Juan Carlos has been the co-leader of the PESETA projects, which deal with the economic impacts of climate change in different sectors of the European Union. So, Juan Carlos, all yours.
Good morning, everybody. First of all, thanks to Andrea and Miguel Angel for this opportunity to join this community of users. It's the first time I'm involved in this one. I mean, I think it's really very interesting. I was this morning and I found the presentations and discussion very useful. So we are part of the Commission and we have been trying to better understand how much climate change can affect Europe. This has been done in the context of these PESETA projects. This is number 3, about to finish. Number 4 has just started. Probably that will be the last one. Maybe we change the name. So these are the questions we want to address in the end. So firstly, of all the impacts, which are the most important ones? Secondly, whether there is a potential, a geographical distribution of impacts which matter, this thinking of regional policy, and finally, to what extent, if we go from a high-end scenario to a stabilization scenario, 2-degree scenario, we can avoid part of those damages. That we have done in the context of the adaptation strategy outlined by Manuel before, and in the end, what we do is rely on relatively sound methodologies. There we benefit largely from previous funding of DG research. I mean, let's think of climate modeling or impact modeling. There are many ongoing projects, and JRC has tried to pull together all these existing resources plus the internal Commission JRC resources to address those questions. This is a first view of how diverse is climate change in Europe. There we have on the left temperature and precipitation. This analysis is done only, the PESETA 3 is only looking at the high-end scenarios, so this RCP 8.5, so this is a world where we have a lot of radiation coming to Earth, and then, because of greenhouse gas emissions, a lot of that is absorbed in the atmosphere, so we have a high warming scenario. And this is what can happen. We see there is a diversity of patterns, both of temperature and precipitation. And in particular, we have looked at these 2 scenarios. We have first the future without action. This is RCP 8.5. This we call high warming scenario. And secondly, we compare those results with the ideal world of 2 degrees. We use 5 climate runs, so all models have run these 5 possible regionally downscale climate futures. This is based on Eurocortex. This is one of the climate community activities from which we benefit in this project. And these are the sectors we are covering. We have 11 sectors. For all of them, we have been able to run these 5 climate runs and assess the consequences for Europe. At the second level, we have done an economic analysis only for the 6 first sectors. This economic analysis means that we are able to put these impacts, climate impacts, into an economic dimension. For some cases, this is not possible. Think of habitat loss or forest fires, water stress situations. This is the methodology is not there ready to soundly assess what are the economic implications of those climate impacts. And at the third level, we have also looked at what could happen in the rest of the world would affect Europe. This is mainly via trade effects. We call this a spillover analysis or transboundary effects. This is something which has not been explored before, and we have been able to do that mainly thanks to ELIX and SME projects, because there we had global assessments of climate change, so we could do the run of what if Europe is not affected, but the rest of the world is affected, how much Europe would be indirectly affected by climate change. So we have these 3 levels of analysis, but there is a 4th one, and this is the unknown, no? Because this is not a complete or comprehensive assessment of impacts. So this bottom line, impacts not considered, there we have many things. First, just to mention a few of them, ecosystem services. All possible implications of these damages are not considered at all in this assessment. Secondly, this big issue was already mentioned of climate tipping points has not been also modeled because it's not possible today. And well, there are other more reasons for not concern but urgent action, thinking of the possible 6 mass extinctions on Earth. This maybe we are on the way already. And probably the life on Earth cannot adapt to this rate of change in climate change, and then that's, okay, this is not at all considered. This is an illustration of the biophysical impact modeling or the climate impact modeling. This is for floods. And there we have the 3 main elements on the right-hand side, the hazard, the exposure and vulnerability. Just to insist that yeah, some of these models are really heavy to run. So looking at the hazard to run these hydrological simulations, there is a lot of data requirements. So we need to have this, firstly, this high-resolution climate information, I mean, both spatial and temporally. We're talking about daily information with, I think it's like 11 kilometers spatial resolution. We need also a lot of data on soils, river profiles, and so on. And then, yeah, this information, this chart, we put all together into a hydrological model, and this is combined with information on the exposure, assets at risk, and also how water levels can provoke damage, these damage functions for river floods. And just there, note, I mean, we have a big problem in the economics to calibrate the damages, this third aspect, vulnerability, because there is no data. There is not good information on what has happened in the recent past. So we have a big obstacle there to calibrate our models in the end, because we are not able to have statistically good estimates of how different water levels in different locations can lead to specific damages in residential buildings, economic activities, and so on. That's something we are trying to improve through possible cooperation with the insurance industry, but this is like a big obstacle we have in the whole methodology. This is an illustration of the results we get there. So on the left-hand side, we have economic expected damage, and on the right-hand side, we have the population exposed to floods. And then you can see, well, let's look at just the economic damage, the figure on the left. And there we can see there is a lot of variability. The thick lines, these are the 10 average damages. And then depending on the economic assumptions we have, whether we assume that the economy is half of today or there is growth in GDP, we have different futures. So the lines at the top, they assume these so-called SSPs, scenarios. So we have economic growth, SSP 3 and 5. And then compared to today, the damages can become much, much bigger, mainly because assets are much more higher compared to current values. Just the last 2 slides about the answers to the questions I firstly noted. So first of all, what are the most important sectors? From the 6, we consider the dominant one is heat-related mortality. This is by far the dominant economic damage. There we have used a conservative valuation of life. We're using 1 million approximately per person. But this number multiplied by like 150,000 additional deaths due to heat waves by the end of the century means 150 billion, which is more than the sum of all the other 5 sectors we are considering in this part of the analysis. By the way, in the US, there is a similar conclusion. They have done assessments both at the US EPA and in the academia with the risky business, and they also conclude that health-related impacts are dominant in the picture. This also was the same for the ozone problem some decades ago. That triggered the Montreal Agreement and the avoidance, I mean, the protection of the ozone layer. Next, we have these other categories. We have coastal floods, labor productivity losses, agriculture, and river floods. And secondly, to what extent we can avoid those damages under 2 degrees? The answer is yes. We can avoid most of them if we would move from this high-end climate future to this revolution of the energy and economic system implied in the 2 degrees scenario. Thirdly, to what extent there is asymmetry in space, geographically speaking. the so-called north-south divide. And there the answer again is yes. There is a very strong gradient, north-south. So we have that if we compare the impacts in the north of Europe to the impacts in the south, it is clear that the regions, the countries most affected by climate change potentially are those in the south, which is also where we have lower incomes or lower income per capita. So there is this tension between the potential damages and the capacity to adapt, which should be probably considered in the policy area. And finally, there is this new aspect of, okay, to what extent we should matter about what's going on in the rest of the world. So there, the answer is yes, partly we should matter. We should take care of that because potentially we could have an extra damage of like 20% because of impacts in the rest of the world. That we have done only for 4 sectors. They are here, demand, flooding, labor productivity, and agriculture. This is mainly because of agriculture. The intuition there is if there is damage in other trading partners, beyond the EU, they produce less, therefore they buy less from Europe, they import less from Europe. So we have this spillover over Europe. This is the transmission mechanism we have considered here. And this is the final slide, so what comes next? Now we have, as I mentioned, running Peseta 4. This is for colleagues in the adaptation unit in Brussels. There we want to enlarge the scope, we want to look into 1.5 to 3 degrees and also the 2050 time horizon. We are having more impacts. We are considering windstorms, heat and cold-related mortality, and forest ecosystems. And particularly also we have the intention to do a better job in the modeling of adaptation. And this is very difficult because for that you need good data on adaptation costs, and this is usually difficult for many of the sectors. But yeah, we have the commitment to do that at least for 3 sectors, if I remember well. Another area is that we should try to integrate further or additional, make an effort to communicate the different models we are running at JRC, because there are some possible linkages, for instance, water, agriculture, or water energy, we should account for in the modeling we are planning to do. And just to insist, the 2 main challenges we have, because we are not probably looking at the impacts which matter the most, these health impacts, climate tipping points. There are some new DG research projects focusing on that, and this is good news. So money will come to fill that knowledge gap. And this, hopefully, we will be able to use this information for the policy support. And finally, this really the trigger of adaptation. Really, there is a big gap there, in knowledge gap. We really need to understand much better the economics of adaptation, and this is there in our agenda. That's what I wanted to present. Thanks for your attention. Thank you.
Thank you very much, Juan Carlos, for the presentation on the Peseta 3 projects. Listening to it and you talking about the spillover effects and also the impacts on health, I can't help but mentioning that last autumn we published a call on Horizon 2020 call on climate change impacts in Europe, and we had 2 subtopics. One was climate change impacts on health, and the other one was external climate change impacts from a European perspective that will have an indirect impact in Europe. So yeah, I agree there are 2 very important topics, and we are at the moment evaluating the proposals. So hopefully in a few months' time we'll have projects starting dealing with these 2 topics, so we can pool efforts on that. So we move on. We go to the 3rd presenter today. Is Professor Richard Betts, who is the head of climate impact research at the UK's Met Office Hadley Centre and chair in climate impacts at the University of Exeter. So Richard was the coordinator of the FP7 project Helix, which assessed the potential impacts of climate change and developed a number of projections, a number of future scenarios of the natural and the human world as a consequence of 1.5, 2, 4, and 6 degrees of global warming. Richard has been previously a lead author on the IPCC 4th and 5th assessment reports and will once again serve as a lead author for the 6th assessment report. So it's a pleasure to have you here today. Thank you.
Thank you very much, Miguel, for the introduction, and thank you for the invitation to speak to you today. So, yes, I'll present some key headline messages from the HELIX project. HELIX stands for High-End Climate Impacts and Extremes. We were looking at global scale impacts. I'll focus initially on impacts in Europe, picking up on some of the work that Juan Carlos already talked about, but I'll also look globally as well. The results which I'll present are based on computer models of climate. These are these use mathematical equations to represent our physical understanding of the motion of the atmosphere, the Earth's energy balance, the water cycle, the change of evaporation, rainfall, and so on. And these models are grounded in our understanding and knowledge of the atmosphere and the oceans based on hundreds of thousands, even millions of observations of the weather and the ocean circulation and so on, taken over years and decades. So they capture our understanding of how the Earth works and allow us to make estimates of future changes. They're the same models that we use for the weather forecast. In fact, this is my friend Peter Gibbs, who used to be a BBC weather presenter. So essentially what we do is start these models off for the present day and then keep them going for the next few days, next few weeks, months, and years, and even a century or beyond. And we can add in artificially increases in greenhouse gases such as CO2 and other greenhouse gases to estimate the effect of future climate change. So one of the important things to remember, though, is we can't predict perfectly, even more than a few days ahead. So we're depending on the models representing the motion of the atmosphere and so on. You can predict that a few days away. Anything beyond that, you're looking at the statistics of changes in rainfall and drought and so on, so the long-term averages. Even then, it's very hard to sort of pin down what this might be because we can't model perfectly the operation of the Earth. So what we tend to do is run several different models and then look at how much they agree or disagree and perhaps look at the average or the ranges of changes and so on. So I'll present generally the averages of several models and sometimes the range of different outcomes. We can be confident about many things. We know that the world is warming. We know it's our fault because of increased greenhouse gases. We can be less confident about the details of rainfall and so on. You'll see this in the next few slides. One of the key things that affects Europe is things like the position of the jet stream, as Peter here is showing. In that situation, we'd be getting storms coming in across the UK, the Netherlands, Denmark, and Germany. So very wet conditions, increased flooding, and so on. A few days later, the jet stream might have swung north. We'd be getting a high-pressure system over the UK and France there, so we would get fine, dry conditions. If that persisted for many weeks, we'd get drought conditions. We pick these up in the models. What we're looking at is the long-term statistics of how these might change in the future. So I'll look at these kind of projected changes at different levels of global warming. 1.5 degrees global warming relative to pre-industrial, so 150 years ago or so is the baseline. We're at 1 degrees global warming so far, so 1.5 would be another half degree on top of that, which could happen in the next 20 years or so. 2 degrees global warming beyond that, which could happen in the middle of the century. And then I'll talk about 4 degrees as well, which could happen well before the end of the century. We also looked at 6 degrees, but I won't mention that here because I haven't got time. This shows the average of some projected changes in river flows, low river flows across Europe. It's the average for several climate projections used to drive a river flow model. And it's looking at the lowest flow, so the lowest 10% of time, so generally in the summer. You get a similar picture as this shows if you look at the mean flows, actually, but I'm looking at the low flows because that's of interest for drought conditions. You can see, as Juan Carlos said, there's a north-south divide here. Drought becomes less of a problem at 2 degrees global warming in the north of Europe. We tend to expect increased rainfall there. All the models tend to project increased rainfall in high latitudes. So we'd expect drought on the whole to be less of an issue in northern Europe. But in southern Europe, we get the opposite, where we project an increase in drought conditions, decreased low flows. And again, all models seem to agree on this. And the physical basis of this is that the downward motion of the atmosphere over the Sahara Desert basically spreads out more and encompasses more of the Mediterranean. So we would expect less rainfall over southern Europe under a climate change scenario. And the decrease in, say, Spain would be perhaps up to an 80% decrease in the low river flows, compared to a 75% increase in mean river flows in Northern Europe. So quite a contrast in changes. At 1.5 degrees global warming, we see a similar pattern, but a smaller magnitude. So we still see increases in the north, decreases of flows in the south, but less severe. If we miss the Paris Agreement targets of 2 degrees and go to 4 degrees, again we see similar patterns but more extreme now. So greater increases and greater decreases in the north and south. The confidence is less in Central Europe and also for the UK. We were kind of on the boundary of this wetter and drier conditions, and different models get different answers there. So we're not really sure exactly what will happen, for example, in UK summers. In terms of flooding, the consensus here actually is stronger. Although I've shown this north-south divide in terms of drought, in terms of flooding, even in drier areas such as the Iberian Peninsula, dry on average, when it rains harder under a warmer climate. So you can still get a situation where a country has got less water on average, but still at risk of flooding when you get more intense rainfall. So what I've shown here is the impacts of increased flooding for different countries across Europe. These individual countries here, so Germany, France, Italy and the UK, the top 4 here in terms of the population affected, and also the same 4 appear in the terms of the expected damage. These bars here are showing what I mentioned earlier about the uncertainty in the projections. The red bar is for 4 degrees global warming, orange is for 2 degrees, green is for 1.5 degrees. And you can see there's a range of results here. So for Germany, the population affected by increased river flooding could be anywhere between about 70 million per year up to about 270 million people per year. So quite a wide range, but a consensus towards increased flooding and more people affected. And even, as I mentioned, even Spain, which is getting drier in terms of drought, is still at risk of increased flooding due to more intense rainfall. In terms of Europe as a whole, currently about 250,000 people per year are exposed to river flooding. We'd expect that to triple approximately under a 4-degree global warming scenario. If we keep global warming to 2 degrees, that would only double, so we'd rein it in by 50%. Thank you. And just to finish with, I'll look globally now. We're looking at elsewhere in the world. Some of these impacts can be quite severe in terms of the implications for humanitarian issues. So we looked at food security. This is an index of what we call hunger and climate vulnerability, which is it's a measure developed by the World Food Programme, a UN body, which ranks countries according to their level of food insecurity, depending on socioeconomic factors such as crop yields, GDP, transport infrastructure, and so on, but also climate factors, particularly drought and flooding. So it's a relative measure. One would be the most food insecure country at the present day, which happens to be Niger in West Africa. That's under the present day simulation. If we look at a 4-degree world, all countries increase in this metric of food insecurity. We're not including any changes in the socioeconomic situation here, just changes in drought and flooding. All countries increase their food insecurity because of either becoming more flooded or more droughted. And in fact, 30 countries reach currently unprecedented levels of food insecurity under a 4-degree world. If we keep warming to 2 degrees, only 4 countries reach unprecedented levels. So again, we rein in the increase in food insecurity by this measure. And last of all, looking at, again, human impacts in terms of heat stress. This is a measure called wet bulb globe temperature, which combines temperature, humidity, and solar radiation. So humidity is important because a wet heat is more comfortable than a dry heat. And to cut a long story short, the critical number is 32 Celsius wet bulb globe temperature here, which is reached occasionally in some parts of the tropics at the present day. But in a 4-degree world, we'd expect to see that a lot of the time over all the tropical regions. So we'd expect to see a much larger increase in heat stress and most of the tropics becoming uncomfortable to live in for much of the time. And just to finish, there's a reminder of all the different impacts I've talked about. Thank you.
Thank you very much, Richard, for presenting the results of Helix. Thank you. Now we move to the last speaker, is Professor Timothy Katha from the Finnish Environment Institute. Timothy represents the FP7 project Impressions, which aims to advance the understanding of the implications of high-end climate change and to work with decision makers to better understand, in applying such knowledge for identifying robust risk management and adaptation strategies. He's a research professor at the Finnish Environment Institute with nearly 4 decades of research experience in the field of climate change, impacts and adaptation in the UK, at EASA in Austria and in Finland. He's a geographer by training, and Carter has also served in various capacities in the IPCC since 1991. So, all yours. Welcome.
Thank you very much, and thanks very much for the invitation to address this very interesting meeting. I'll be talking then about the Impressions project, which stands for Impacts and Risks from High-End Scenarios, Strategies for Innovative Solutions. And I'd just like to acknowledge and send regrets from Paula Harrison, who is the coordinator of the project. But we're a big team, and so other people can be called in to do their duties. Okay, so Impressions, as others have already indicated, in spite of the Paris Agreement, current emission trends indicate that we're heading for futures that could well be much higher end than we would like. And there are actually rather few studies that assess their potential impacts and the ability of adaptation to reduce vulnerabilities and possible synergies and trade-offs between adaptation and mitigation. So Impressions aims to advance understanding and the consequences of high-end climate and socio-economic scenarios and to work with decision makers to explore how such knowledge can be applied within sort of integrated planning. So we've worked in Impressions with 5 case studies at different scales. We have a case study outside Europe, which is picking up on some of these effects that have been talked about earlier, in Central Asia, looking at potential implications of climate change in Central Asia for Europe, via the effects on neighbours and so on. We have a European case study, Europe-wide, and we have 3 case studies also at regional, sub-European level, one for Scotland, one for 2 Iberian catchments in Portugal and Spain, and one other study focusing on 2 municipalities in Hungary around the Lake Balaton area. We've been using integrated scenarios, so why do we do this? Well, we feel that it's in studying futures out for a long period, it's important to look at both climate and socio-economic change. We're doing this within the context of challenges to adaptation and mitigation that might be posed by these future different social and economic futures, as well as looking at the climate. And so we've adopted the so-called shared socio-economic pathways, which are global narratives and scenarios that have been developed by the international community, and we've regionalized these in each of our case study regions. And we've adopted 4 of the SSPs in the corners on that diagram, SSPs 1, 3, 4, and 5. We're not looking at SSP 2 because we feel it's not quite so interesting because it's in the middle somewhere. And with those, we've then paired the 2 SSPs that have highest challenges for mitigation, as SSP 5 and SSP 3, with the high-end representative concentration pathway, which is a forcing of the climate. So these are the highest sort of climate projections. And we've paired SSP 1 and SSP 4, which have low challenges for mitigation, with a lower end RCP 4.5 forcing, which comes out at about a bit more than 2 degrees. So it's not a 2 degrees projection, but it's some of the projections from the climate models using RCP 4.5 do go down as far as 2 degrees. So we've then taken those scenarios and we've been modelling climate change impacts and risks and also adaptation as well, using a range of models, impact models, across these different case studies, over 20 models in all, including integrated models that are multi-sectoral in both the European and Scottish case studies. This multi-scale modelling framework allows us to link climate change impacts across scales from global, so some global models, right down to regional level. And we feel that the cross-sectoral modelling is particularly important. I think Juan Carlos raised this in relation to Peseta 4, that it's all very well to look at impacts in sectors one by one, but actually some of the interactions between the sectors can be particularly important. So we've been looking at that particularly with our integrated modelling schemes. So this is the sort of approach we've adopted to come up with some idea about possible pathways towards integrated solutions to the issue. We've worked with stakeholders a lot, co-designing visions of the future, where we would like to be in Europe or in our case studies, so some sort of desirable vision of the future, and comparing that with where we are today. And then we have used the RCP-SSP framework to say, well, what is the trajectory on which we're heading if we follow those different scenario combinations? Where would we end up, if you like, towards the end of the century? What can we do with adaptation and mitigation to alleviate possible negative impacts, or even to enhance positive ones, if there are positive ones, and get towards that vision? But characteristically, we find that even when we include adaptation and mitigation in our modelling exercises, we simply cannot get to those desirable visions in the future. And so we spent quite a lot of effort in the project with stakeholders, again, in the case studies, thinking about that shortfall. What sort of additional information, or additional measures, additional strategies, transformational strategies, a very sexy word to use, but that is quite an important word, I think, also in this context. And with that, then, to try to construct different pathways into the future, made up of strategies for adaptation and mitigation, synergies between them, sometimes there are trade-offs between them, and to see if we can actually get towards that vision. Here's an example of a vision. This is for the European case study, since it's a European audience, if you like, here. The sorts of things that people were being asked to think about were equity, governance, resilience, natural resource, environment, living and lifestyles, those sort of issues. Where would we like to be in Europe with respect to some of those? And you can see the narratives for those for yourselves. So here's just to take you through some of the sorts of figures that we've already seen in earlier talks, so I'll do this rather quickly. So for our scenarios and impacts, we have then these combinations for the RCP 4.5, that's SSP1 and SSP4. Characteristically, there's a narrative that goes with those socioeconomic scenarios for each of the case studies. They even give them names in some cases. We Are the World is SSP1, Riders on the Storm, SSP4 for Europe. For RCP 8.5, the high end, and you can see the climate, some example climate figures there. So they're being used in combination with the SSP5 and SSP3. Fossil fuel development and Icarus, which is a divided type of world. With that sort of information, we've fed that into these different types of models, and here's just one example for Europe-wide. This is a sort of vulnerability index which is taking into account various aspects of water scarcity, intersectoral, and with a vulnerability index which is taking into account different capitals, different capitals of human, social, financial, and so on. So quite complex combinations. And you can see that under these scenarios, you get quite some differences in response. And just take a look at southern Spain, for example, under SSP1. Actually, you might find examples where the SSP1, which maybe you might think would be a more desirable scenario, might actually be more severe in some cases in terms of vulnerability than, for example, the SSP3 in southern Spain. So if you just did a climate analysis alone, you wouldn't get that. So just then some final words then about some of the solutions that stakeholders have come up with in the different case studies. These are some of the sub-European ideas that are coming out of this that moves towards healthy and sustainable lifestyles in Hungarian, Iberian and Scottish case studies. Issues about sustainable water management, clearly very important in Hungary and Iberia. Integrated environmental planning and resource management was highlighted. Inclusive and multi-level governance for sustainability in Hungary. And also local community empowerment figures in a lot of the case study discussions. For the Central Asia case study, which is outside the European boundaries, but in that region, transboundary water governance is paramount, very, very important for those republics. But also regional connectivity, both internally within the region, but also with neighbours such as China and Russia, and of course with Europe itself. Europe as a whole, one of the two of the sort of core, if you like, outcomes there and solutions that were being sort of agreed upon were firstly some sort of the need for some sort of a transformational accounting framework that takes into account more than just GDP, but also includes natural capital, well-being, social equity would be needed in Europe. And also just the issue about being content with living with less. And so the whole issue about education, about sustainability, not only education in the formal setting, but also in business, in public sector and so on. And then just a few similar sort of policy recommendations out of the European case study. Just to close, I'll skip over those now. And we also looked at game changers, what sort of combinations of strategies might be thought of as being particularly useful to sort of to kickstart actions over the next few years. And some economic-based and also community-based actions were highlighted there. And just to close, if you want more information, obviously a website, there is this document, The High-End Climate Change in Europe, which was published with Helix and Rises AM that Richard has in his hand there. There'll be a poster on impressions, and also we've just very recently, from our 5 case studies, published a set of, they're supposedly draft, but they look very, very final to me, draft policy briefs on the 5 case studies. So I'd invite you, there are copies outside, and so there should be some available of all of these for you to have a look at and maybe give your feedback on. Because we had thought that maybe we get feedback and see if they're fit for purpose, or maybe we need to shorten them or do something with them, because we have a few more months left in the project to finalise things. Thank you.
Thank you very much, Tim, for your presentation. And it's now time for questions. I know it's 12:30 now, but we started 15-20 minutes late, so there's still some time to interact with the panel and to raise your questions. Virginia? Thanks, Diogo, for the support.
Is it working? Yes, it is, fine. My name is Virginia Murray. I come from Public Health England, and I'm here to talk about health and extreme weather. I thought your presentations, particularly the last 2, on Helix and impressions, are really important. But what I lacked was, where is health in all of this? Because if we're not well, we can't respond. We can't manage these events. Any advice, please?
Thank you, Virginia.
This one? Yeah.
Okay. Yes, thank you for that, for the reminder. Yes, as you saw in the Helix project, we did a small amount of work relevant to human health with the heat stress. We also did some work on vector-borne diseases as well, which I didn't have time to talk about. But I think you're right to highlight the fact that human health, somewhat bizarrely, doesn't feature as highly as it should do in climate impact studies. And I'm never quite been able to understand exactly why this is. Perhaps we're just not joining up the communities enough, I guess, or maybe the funders aren't pushing us enough to sort of do this kind of work. But we should definitely do more on this, but clearly it's a huge issue.
If I could also respond, I think in the table that health was mentioned, and also we actually did study aspects of Lyme disease in Scotland and Hungary, for example. Heat stress, of course, heat stress, it's always heat stress. I mean, morbidity might be very interesting to do, but we didn't have the time or the resources to do it, and because we're multi-sectoral, so it was, we had to make choices as to what we studied. But I would endorse what Richard said, though, that health really maybe has been somewhat underrepresented in the past years, and that probably is one of the reasons why there is this, this new call in Horizon 2020 on that very topic.
Thank you very much. Any comment from Juan Carlos or Manuel? No. Next question. Let's move on.
Thank you very much. Monica Buscher from Lancaster University. I've got a comment and a question. One is, how does your work relate to the concept of human security? You all mentioned the global aspects and the complex connections between the different risk factors. And the concept of human security is a paradigm shift of from thinking about security as a matter of protecting nations against threats from the outside to thinking about security as a global issue with migration, poverty, climate change all being connected. And that works at a global level, but it also relates to the question that Virginia asked at a local level. I don't know if you know the study of the heat wave in Chicago by Eric Kleinenberg, a social autopsy of a heat wave where in 1995, 740 people died within 5 days. And some of them died not because of the individual health, medical conditions and the temperature, but also because one neighborhood had shops and hairdressers that had that had air conditioning, and so people could go there. So the health of the social community was a really important factor of it. So if you think about human security as a social practice, that's really important. And in relation to that, I'd also like to ask, sorry for so many questions. You talk about stakeholders, Timothy. Did that, Philip at the beginning asked about public engagement and citizen engagement. What are the challenges of making citizens understand and actually get engaged in a transition that's required?
Thank you very much. Really complex and challenging questions. Who would like to start first? Richard?
So, yeah, thank you for the excellent points. Yeah, again, the human security is a really important point to raise. We did do some work on that in Helix, which we didn't have time to talk about. We did some work on migration, environmental migration. So the University of Liège did a lot of work on this. One of the important things there is you can't predict everything just from sort of physical climate modelling and so on. A lot of it is actually about perceptions. People will migrate for reasons which they assign to climate, even if they won't have done a sort of full statistical study of whether their region's getting dry or whatever. If they just think it's getting uncomfortable, they will move. So it's about perceptions as much as actual sort of data. But also, the other sort of human side is about resilience and adaptation. And a lot of the impacts can be much better, much greater rather, if the sort of the society is not resilient. An example which has come out recently is Hurricane Maria and its impacts in Puerto Rico, where the actual direct impacts of the hurricane were, I think a few dozen people died, but as a long-term consequence, I think it was like 4,500 people have died since then because the response to the disaster has not been sufficient in protecting people after the fact. So it's a much more complex thing than just the physical climate. So we need to bear that in mind in policy responses and in understanding what these impacts might mean in the future.
Right, very complex questions to address. On the human security, right, I mean, there are many aspects of security. We certainly looked at security quite a lot in the Central Asian case study because that was actually a study that was suggested to the project because we had thought of doing something outside Europe, but we hadn't thought of that region. It was suggested to us by the Commission after some feedback from various DGs on this, because that region apparently is something that the European Commission is concerned about in the sense that obviously it has relationships with Russia and China, north and south, strategic relationships, It has impacts of its own within Central Asia, but it's the interaction between those impacts between those neighbours and then the potential implications for Europe that were of interest to the Commission, and that was the feedback we got, and so that's one of the reasons why we initiated that study. Clearly, quite a difficult one to operate. We managed to get fairly good stakeholder, not citizen science, I wouldn't say, but certainly representatives from Russia, China, and Central Asia itself in the room, Chatham House rules and so on, to just discuss through some of the issues about, because of course Central Asia, like many of those regions like many other countries around that area, actually there isn't that much impact analysis work available, at least in the peer-reviewed literature in the English language, possibly maybe some more in the Russian language, but maybe not that much more though. So we're dealing with data sparsity also to actually look at the analyses there. I could say more. I probably should pass it on to others to say more about the health issues that you brought up to do with vulnerability not being just a physical issue. I think that's very, very much in the back of our minds. So that's part of the reason why we've tried to look at vulnerability in our integrated modelling as some sort of combination of or aggregate of indicators of different capitals. So natural capital, obviously, the environment, but human and social capital as well are in there, and we have indicators that we're using. It depends on the impacts that we're looking at as to what indicators are used. But and I can't give you an example to hand. But that's the sort of philosophy we're using to try to bring in the vulnerability side into the equation. And I think there's much more work is needed, particularly in the health area, which I think is on the agenda now. But so it's certainly being thought about, but it probably hasn't been handled very well yet.
Thank you very much. Any other comments from this side of the table?
Yeah, perhaps. Thank you very much for your question. I would like to respond to you on the awareness bit, on the engagement. I personally think it's a key issue, not only because protocols in the face of extreme weather can help save lives, and this in developing countries is a key issue, for example, but also in Europe, let's say, to be sure that citizens are generally informed about what's coming to the cities is quite important. In that sense, the European Union has been supporting for years now the Covenant of Mayors. Probably you've heard about it. This is a network that covers both the emission reduction at city level, at urban level, and also adaptation. And through the Covenant of Mayors, we're helping local authorities be, let's say, enable awareness to the citizens. Let's not forget that cities are key for climate action. Why? Because they are in the front line, not only of the impacts, but also of the capacity to engage directly with citizens. It's a level of governance that is often less political and more worried about the immediate effects on citizens of climate changes. So this is from my side. I think this is a big effort we're making with the Covenant of Mayors that's going to continue in the future, and that at the moment there are 7,000 European cities covered, and thousands of them also have made engagements in adaptation and mitigation.
Great. Thank you very much for your answers. I think we still have time for 1-2 questions. Rob? 3? I see 3 questions, so 1, 2, 3.
Yeah, I think part of my question might already be answered by the last answers. I was kind of triggered by the spillover issue in the Peseta presentation, so maybe a question to Juan Carlos. I guess that migration, climate change-driven migration, is not part of your spillover analysis, because I kind of know what's behind it, so I wouldn't expect it. But is this something, for instance, to be included in the Peseta 3 you mentioned, or are there other initiatives that kind of are going to look at climate change and migration and as a next step, the economic effects of that?
Yeah, that's a very relevant point. Migration and climate change. There is a recent publication by Wolfram Schlenker. He's at Columbia University. He published, I think it was in Science in December, a paper. This was co-funded by Department of Energy in US and also Jersey. It's a small study, but they got some interesting conclusions on how climate change could lead to migration towards Europe. And the vectors, I mean, the transmission seems to be agriculture prices. So if there are problems in sub-Saharan Africa with agriculture, this could trigger. But this was assessed also in ILIX. We had a very good team there, and the quantitative assessment of this is really complex and challenging. So this is probably beyond the state of the art today. But that's also a point in the agenda as health impacts and tipping points. Yeah, thank you. Thank you.
Hello. I think a question for Juan Carlos. You mentioned in spillover analysis, sorry, Lawrence Marzell from CoU. You mentioned in the spillover analysis that you were looking at the consequences and effects of impact from elsewhere outside of Europe, but you mentioned that you were assuming that there was no effect, no consequences of climate change in Europe, but surely that would be unlikely, so therefore the effects externally would be compounded.
Yeah, that's a good point. So, say from our experience, it seems that these shocks are more or less orthogonal, so they don't really compound. One would expect this compounding effect, but yeah, that's the way we technically run the models. And yeah, so if we compare without impact in Europe or with impact in Europe, and we add, it's more or less the same. But yeah, that's a good point. So this is unexpected somehow. Yeah.
Oh, yes, sure.
Just on the spillover effects, I don't know if people are aware that there was a small section of a recent EEA report that looks at this review. We also did a review in the Impressions project in the context of the Central Asia study. Well, the Central Asia study was in the context of a broader review on international impacts. And we found that there have been a number of national studies looking at the international impacts of climate change on certain countries. Switzerland, Netherlands, UK, and Finland are some of those. And there are, of course, various pathways within which impacts could actually occur. Impacts outside can actually sort of reverberate through and spill over to a place, any place. Human, migration, for example, biophysical, trade, of course, naturally, financial flows, very important to think about. Security in general, I mean, they're part of security, I suppose, and infrastructure is another one as well. So of course, I'd encourage Peseta to treat all of those. I'm sure they can't treat all of them, but I think that they're some of the aspects that were highlighted. And it's very interesting, actually, when one looks at if you develop vulnerability indices for just any country in the world, and you look at the direct effects of climate change on those countries, European countries tend to come out rather low on the vulnerability scale, if you like. If we want to talk about vulnerability, I prefer to talk about impacts or potential impacts. But if you look at the vulnerability, if you look at the susceptibility of those countries to impacts happening outside, because of all these pathways that they might be susceptible to, actually some European countries are very, very dependent on connection with the outside world, and their vulnerability or their potential impacts could actually be raised quite substantially relative to what you might imagine. Countries like the Netherlands, for example, or countries that are very wealthy, but actually also very, very dependent on international trade, for example.
Thank you very much. And we go to the last question now. So. Working?
Yeah, okay. Sébastien Lay from Safe Cluster in France. several of your presentation pointed out the fact that Northern Europe seems to be less vulnerable to this change than Southern Europe, which is obviously the case. I just wondered how much your different models took in account the vulnerability of boreal forest. I mean, this huge forest in the Northern Europe and north of Russia also is going to be drier probably and going to burn a little bit more in the coming years. So did your model consider this point? Thank you.
Who wants to take this?
Yeah, I think possibly we gave quite a partly skewed view because of the particular impacts we talked about, because the impacts in Northern Europe are smaller for things like human heat stress, drought, and so on. But actually, for other things, they can be larger. So the actual the increase in temperature is greater nearer the poles. You get a much larger effect in the Arctic because of melting snow and ice. Really reveals the underlying dark land and ocean surface, which absorbs more sunlight, so you get more warming. So actually, impacts on things like biodiversity and, like you say, forest fires in the boreal forest can be larger because the warming itself is probably greater there. So it depends on which impacts you're talking about, and particularly the natural system impacts. And anything which relies on frozen ground, permafrost and so on, you could be going past tipping points there. So there could be some severe impacts which we didn't cover in our presentations.
Me again, I'm afraid. Yes, we looked at some aspects of forestry, but particularly, I think probably the key point is that we were looking at forestry and other land use within a land use modelling framework. So we were using agent-based land use model for Europe, which indicated based on demand for agriculture externally imposed under the different scenarios. The scenarios are very, very important to bring into this, because the scenarios are telling you how much food Europe needs to grow. How is it going to grow that? If it's going to grow it under an SSP1 world, it's probably going to be organic or agriculture, so it requires extensification, because you're not allowed to be putting in lots of inputs into the agriculture unless you have some new technological advances. So you need more land. So what do you do? How do you find that land? It may be at the expense of forests. So actually, some of the reason why we were getting some seemingly counterintuitive results in some regions of impacts was because of the land use component in there, which was taking up land for other uses when you might actually need it for another use. So I think those aspects, again, it points to the really very important role of intersectoral analysis, and and particularly in the context of mitigation, of course, and biofuels and some of the estimates that of the land required to mitigate down to some of the Paris types of targets. That implies massive land use change, and under some of those scenarios, you might get that, but what are the implications then for other sectors which are depending on land as well, for pollution, for erosion, various other aspects? Very, very interesting work that still needs to be done, really. We've only just tasted it, but it is fascinating to look at when you start to look at the sort of interactions.
Great. Thank you very much for your responses. I think we could be here discussing this topic for a long time, but it's time to close the session. Before I close, my colleague Diego de Guzmão Sorensen would like to make a final comment.
Thank you very much, Miguel. I just want to comment on the climate and health questions that came up. I remember 2 years ago drafting the current call that's in the work program on climate and health. And I can tell you that we faced obstacles both internally and externally, because I'm increasingly coming to the conclusion that these are two very separate communities, the climate science and the health science communities. What we are trying to do is to try and bring them together and to address the challenges together. So I would just say, bear with us. It's something new for us to promote, but it is definitely something that's not going to go away. This is the beginning of something, and I think the momentum around Europe and the world is growing. So I just wanted to reassure those who are concerned about climate and health that the Commission is definitely considering this, and it is now a priority. It is in the work program. Thank you.
Thank you very much, and please help me to give our excellent speakers a well-deserved round of applause. And we will be back at 2 with panel 3 on coastal threat and hydrological extremes. Thank you very much.